Thank you very much indeed, Michael, for organizing this session and for the intro. I trust you can all see my screen.
We can.
Perfect. All right, so I'm Christian Wade. I'm a program manager in the Power BI group. We also own both the flavors of analysis services, being SQL Server Analysis Services and Azure Analysis Services. You may be aware that the three products that they're actually not, there are even more products that use the Analysis Services engine or are based on the Analysis Services engine, but the three that I'm referring to are SQL Server Analysis Services, which is for on-premises installations, and we SQL Server 2019 is approaching general availability. There's lots of good features in SQL Server Analysis Services 2019, including calculation groups for reusability of DAX calculations, and lots of other things. And then in Azure Analysis Services, all of the same features where applicable show up as SQL Server Analysis Services 2019. So Azure Analysis Services is kind of our direct lift and shift product from on-prem to the cloud, because it's got modeling symmetry. You do the modeling in SQL Server Data Tools, it barely knows where you're going to deploy it to. And then, of course, we have Power BI, which is what we're going to focus on. And Power BI is maturing into the next generation of analysis services. So we'll talk a little bit more about that. So I own basically the enterprise modeling features. So I drive the modeling features for complex models and for scalability. Right? There's lots of other things in Power BI, as you can imagine, and just in terms of the platform, and not to mention paginated reports and data flows and collaboration and a ton of other things, but that's what I focus on. Is really the analysis services user base, and so I look after the same those features in both the analysis services flavors and in Power BI. Okay, all right. So to drill in a little bit further into what I've been saying, so Analysis Services is now 20 years old. It's been an absolute, I think it's fair to say, it's been an absolute dominator over the past 2 decades. We, Microsoft, are the only vendor to be ranked in the Leaders Quadrant, in Gartner's Magic Quadrant, for the last 12 years in a row. And 12 years ago, self-service BI wasn't even, being talked about. It wasn't, it was all about enterprise BI. And so that shows our deep heritage in enterprise BI and how we've been leading this space for a long time. And then in 2016/2017, we launched Azure Analysis Services, which is a fully managed platform as a service in the cloud, which, as I said, gives you a straight lift and shift story from SQL Server Analysis Services 2019. In the meantime, we've also been working on Power BI, which is traditionally a self-service BI tool and platform. And so the idea is to empower the data analyst to discover and promote insights quickly and easily without a dependency on IT, right? So when I say enterprise BI, I mean typically business intelligence implementations that are owned and managed by IT, right? Whereas self-service BI is really geared to the self-service analyst. Now, we and the industry have kind of separated the two tracks. And I think it's fair to say also that we are the only vendor to have a traditional enterprise BI background and really embrace self-service BI early on with Power BI. Right? And we've been recognized by Gartner and Forrester and other organizations in terms of how we embrace self-service BI early on. So whereas a lot of the other vendors are either focused traditionally on, or more so on either the enterprise BI, or you have the kind of modern BI players that are more focused on self-service BI. We are I think it's fair to say, one of the few vendors that really has a foot in both camps, has a strong presence in both camps. So we are very well positioned to kind of execute on our vision, which is that you know, actually the industry as a whole has come to realize that this separation of enterprise and self-service BI is too rigid, right? You know, if you look at the life cycle of a business intelligence artifact, an analyst may discover something interesting, and then it gets popular, and then the data loads become too much to manage. They want to hand it over to IT and promote it to a centralized BI story. And you know, there are challenges in that anyway. In terms of it makes it much easier if they're technology aligned, right? So what we're doing is we are converging the two platforms, right? So we're going to soon Power BI Premium will be a superset of analysis services. They already both share the same analysis services engine, right? The Power BI data set actually runs on analysis services tabular in the back end. So that makes it a lot easier for us to converge the two platforms. And, you know, back to my example of taking a self-service BI artifact and promoting it to centralized BI, even with it being technology aligned, being on the same platform, there's still some work that needs to be done, of course, in terms of, you know, integrating. Enterprise BI is all about maximizing reusability of a small number of large models. So typically you might, you know, take those definitions discovered by the analyst and merge them into a corporate BI model. You might, you know, change the definitions that align with corporate standards, etc. But being on the same platform instead of some disparate technology, that it makes the whole flow and the whole collaboration between the business and IT that much smoother, right? So that's where we're going with this. It simplifies the message, and you know, this is the future of analysis services, is a single all-inclusive platform, a one-stop shop that has access to the whole Power BI ecosystem, and has and really actually goes beyond analysis services in terms of even scalability. We have features in Power BI for scalability that are not available in analysis services, like composite models and aggregations, that lets you unlock these massive data sets, like trillions of row petabyte scale data sets, on top of SQL Data Warehouse and other data warehouse platforms. We have dynamic memory management to swap data sets in and out of memory, and many other things, connectivity to a ton of different data sources, and as I say, it's native integration to the rest of the Power BI ecosystem, right? So that's the future of analysis services. At the moment, we're still working on really making it a true superset of analysis services. So we will be announcing soon a feature called large models, which is what I'm going to demo, and I'm going to talk a little bit further, which is one of the three kind of pillars to making Power BI a superset of analysis services. Okay, so some of the enterprise features in Power BI that you will see either there already or showing up soon are semantic modeling. As I said, Power BI data sets are literally based on the analysis services tabular engine. So all of that semantic modeling richness from analysis services is baked there right into the engine. We just need to unlock it, and we have been doing that. You can have things like, you know, complex relationships between a ton. You can have a ton of tables, you know, maybe 100 tables. You can have complex calculations and KPIs and hierarchies and row level security definitions and display folders, and all of these things are examples of how you enrich that semantic model to make it easy for the non-technical user to access and unlock these large data sets for consistent decision making in large organizations. So you know, the modeling experience in the Power BI tooling set with Power BI Desktop is acknowledged to be pretty good, but there are a few little extra things that we want to put in there that are traditionally more for the enterprise space. You know, things like calculation groups and translations and you know, perspectives and those things. So you'll see those showing up in one way or another over the next 6 months or so. I'm not going to disclose anything further on that right now, but suffice to say that again, the Power BI data set is literally based on the analysis services engine, and therefore has all of that semantic modeling richness built into it, and is ready to be unlocked to these enterprise deployments in Power BI. Governance. So governance is actually, so there are a couple of things on governance. So with so I'm going to things work a little bit differently and incrementally better as you go from SQL Server Analysis Services 2019 or SQL Server Analysis Services on-prem to Azure Analysis Services to then Power BI. So for SQL Server Analysis Services, we've had extended events, and you can access the perf1 counters. And it's the problem is that it's quite a lot of work to set all of this up, because you need to set up extended event sessions. You then need to access the extended events using these special kind of system functions, and it gives you the output in T-SQL and XML format. You need to pass XML, and then you need to put that data somewhere where it can be easily accessed, and you need to build a little data mart with all of this telemetry data. So it's a lot of work, but people do it on-prem. In Azure Analysis Services, it's much easier. You can use Azure Diagnostic Login. You just pump all of the telemetry that you need in terms of the events, and also the metrics that come, and you can push it all to a log analytics workspace, which is where all of the major Azure services support putting all of that data in a log analytics workspace, so you can have all of the data, all of your telemetry data across your whole architecture integrated in one place. And it's a lot less work, a lot easier to set up. You can then use the Cousteau language to query it and have reports in Azure. So that's a big step up in terms of the kind of auditing and telemetry, and that's going to give you governance in terms of the system health and who's using the server and what kind of issues there are, what users are using, what data, what users are experiencing errors, and etc. Right? And there are then some governance controls that you can set up in analysis services to protect the server from runaway queries and things like that. Now, all of that is either in Power BI or coming soon to Power BI, everything I just described in terms of the Azure Analysis Services capabilities and the Azure Diagnostic Logging integration. But the additional thing, which I actually have a couple of slides to show you on in governance in Power BI, which is a really unique differentiator for Power BI, is that Power BI artifacts, you can tag the Power BI artifacts in terms of the sensitivity levels, which gives you integration with the Microsoft Office data protection capabilities, which is a really unique differentiator that we can offer in terms of corporate level governance and corporate level visibility in terms of protecting data in your organization. So I've got a couple of screenshots of that, which I'll show you before the demo. Scalability, as I mentioned already, we will be soon launching the large models feature in Power BI Premium, which will take the dataset sizes to parity with Azure Analysis Services, right? So the biggest Azure Analysis Services SKU is the S9. There's 400 gigabytes of memory, allowing some memory as a buffer for refresh operations. You're looking at datasets of maybe 3 to 350 gigabytes in size, and that's after compression, right? So that's potentially tens of terabytes in its raw uncompressed form, which then gets compressed into memory to give you that blazing fast performance. And so with this large models feature in Power BI, we'll have parity with those dataset cache sizes. However, Power BI can take you beyond those dataset sizes with features like composite models and aggregations, where you cache only the aggregated data into memory, and you can unlock multi-petabyte scale data sets for interactive analysis. And all of the aggregated level queries hit the in-memory cache. And if you think about it, the vast majority of business intelligence queries are aggregated in nature. So you're going to get a very high cache hit ratio over massive data sets. So these are some of the additional features that you get in Power BI over analysis services, as well as the dynamic memory management, where we can swap data sets in and out of memory so that you can have your total data set memory footprint can be greater than the total memory on the machine, because we're able to swap data sets in and out of memory. So this really takes you beyond Azure Analysis Services in terms of scalability. Open platform connectivity, we announced earlier this year the XMLA endpoint. So the XMLA endpoint is a protocol for client tools to connect to the analysis services engine, and it was set up all the way back in like 2002, and our first product that shipped it was multidimensional in analysis services 2005, And there are a ton of other vendors in Gartner's Magic Quadrant, or a few of them, who you could argue that initially at least built their business on being a front end to analysis services, because they were able to connect through this XML endpoint. Right? It gives you that open platform connectivity. Many other vendors who I'm not going to name right now have reasonable front-end data visualization tools on top of analysis services. Now, you may ask the question, well, isn't Power BI better? Why would we even need that if we've got Power BI? So if you think about it, if you're doing a corporate implementation, a corporate rollout, and you have a big data warehouse and you have a big handful of semantic models that you want to promote reusability in an enterprise organization, you've got users all over the world, right? And so many of them will obviously be using Power BI to access the data through the semantic model. But some other departments, some other certain users, they may still be using other data visualization tools, and they may not yet have had the opportunity to really understand the benefits that Power BI can give them. So in the meantime, they can continue to use those tools. They can connect to the analysis services semantic model in Power BI, i.e. the Power BI dataset, which, as I said, is actually an analysis services model, which is accessible through the XML endpoints. And they can access that semantic model using other non-Microsoft data visualization tools, and you can still promote that single version of the truth, and it just makes your rollout more kind of friction-free, if you know what I mean, in terms of rather than having to do a big bang rollout, if that makes sense. Application lifecycle management. So with analysis services, that you can do things like check the model metadata into source control. You can do diff and merge. You can do incremental deployment across environments. You can roll back to previous version. All of these types of things. So we are building some unique ALM capabilities in Power BI for deployment across environments, which are effectively workspaces in the Power BI world rather than servers. But beyond that, we are also ensuring that Power BI will be backwards compatible with analysis services ALM capabilities, which is just dependent on the dataset metadata, which you can then check in source control. You can do diff and merge, you can do incremental deployments, etc. All right, so that's all in the works. And then manageability. So again, we want Power BI to go beyond analysis services in terms of scalability and in terms of manageability. So, for example, for large in-memory caps, let's say you've got a 300 gigabyte analysis services model on an S9 or an S9 V2, even the new version of the S9 in Azure Analysis Services, you will be able to just migrate that to Power BI sometime in the first half of next year. And all of your existing ALM processes, all of your existing kind of management processes in terms of incremental refresh and generation of partitions and all of your PowerShell scripting and all of your Tableau object model code to incrementally load partitions in a parallelized fashion to reduce the time to get the data set online. All of that will be backwards compatible with Power BI. However, Power BI also gives you a much more simplified management experience. So certainly if you're building the data set from scratch, you would not need to write those 2,000 lines of code to manage your incremental refresh. You can just fill in a simple dialogue. And so I plan to show you that in the demo as well, because incremental refresh in Power BI actually goes hand in hand with the large models feature, because it's the only way to get to a large model. No one's got no one's got a 100 gigabyte PBIX, right? If you do, then respect to you. But typically we're going to upload a small PBIX, but we're going to define a policy to say that once I invoke a refresh, I then want to load the 10 billion rows of data. Once it's in the service, that will then get it to 100 gigabytes, right? So that's how you're going to use large models, is with incremental refresh hand in hand. They go together, if you know what I mean. All right. We've had incremental refresh out for a while. We've got very high usage, and that's even with the limited data set sizes that are in Power BI today. With large models, we anticipate that both those features will complement each other. Okay. So I've got a couple of screenshots here on the governance piece, and then I'll pause for a couple of minutes to take any questions. and then I'll jump straight into the demo. So for governance, as I said, we are bringing Azure Diagnostic Login for auditing to Power BI at some point. I don't have any timelines right now, but additionally, this is a differentiator in Power BI above analysis services and also above, basically every other BI vendor, which is that you can tag or you will soon be able to. We are working on. We've already disclosed this in the conferences that we're working on this, and it's already in the Power BI release notes in terms of what's coming in the upcoming semester, in terms of timeframes and things. But what you can do is you can tag a Power BI artifact to set the sensitivity level, just like you can a Microsoft Office Word document or an Excel sheet. And you may actually not realize the kind of corporate policies and the corporate visibility that comes along with you doing that. It's not just that, oh, when I'm going to email, it doesn't allow me to email this document to someone outside my organization, or it forces it to be an encrypted email, or there's a ton of these policies that can be set up based off this sensitivity level. It's actually a lot more than that. So I'm going to show you through these screenshots if I can. So basically you tag the Power BI artifact, you set the sensitivity level, and then once it's in the service, if you did an export to Excel, for example, the sensitivity level comes with it. And then it starts aligning with all of the corporate policies around, which regions are allowed to access the data. Or maybe you can, if you're accessing the Power BI sites from an unmanaged device, like your home machine, then it will let you access the site, but you can't do an export to Excel and things like that. Based off all of these corporate policies, right? And I don't actually have a screenshot, but this is fully integrated with Microsoft Cloud App Security, right? So administrators for the organization can have a single pane of glass. They get the full auditing of all of the incidents, of all of the, and it's all integrated with the whole Microsoft Office ecosystem. So all of the incidents where users tried to, access from an unmanaged device or from a region that was unsupported. It gives you a summary of all of the counts of the artifacts by sensitivity level, and all integrated with Microsoft Office through what's known as Cloud App Security. So Power BI then becomes a first-class citizen of the Microsoft Office data protection capability through Microsoft Cloud App Security. Right. So this is a key differentiator for enterprises as well. All right. And large models, as I said, we're going to launch this very soon. And so the deal is that Power BI Premium data sets today, if you're on a P3, you can have up to 10 gigabytes, right? So we're lifting that limit so that the data set size will be limited only by the premium capacity size, which is basically the same as how Azure Analysis Services works. And the Power BI Premium SKUs are kind of hardware aligned to some degree with the Azure Analysis Services SKUs. So this basically gives you data set size parity with Azure Analysis Services model sizes. And again, this is when you cache all of the data into memory for blazing fast performance. It doesn't include that. It's not. I'm not referring to aggregations and composite models and the other scalability features you get in Power BI. This is just going to help make Power BI a superset of analysis services. So we're going to get the large model sizes. And just one point to make here is that when you upload the PBIX, like I said, no one's got a PBIX with 100 gigabytes of data in it, right? Your PBIX upload size is still limited to 10 gigabytes, and typically you would just be uploading a PBIX that would just be a few megabytes. It's only once you invoke a refresh in the service that then it grows to potentially 100 gigabytes or however big it's going to get to. Okay, so I'll give you a demo of that shortly. All right, so that's large models. This is one of the three kind of key pillars to making Power BI a superset of analysis services, and this is launching very soon. Right, and XML endpoints, this is another one of the key pillars. So this gives you the open platform connectivity that I discussed. So you've got the analysis services server, which is accessible by the server name from not just Power BI, but from Excel and from basically every other major BI vendor on the planet, which, as we discussed earlier. So that gives you access to the analysis services model for data visualization purposes, but we also use the XML endpoint for data management, right? So the read-only XML endpoint in Power BI is already available. You can already use that today. You can already connect using the competitor products or as though it were an analysis services model. But for management, we're going to be launching this in the first half of 2020, hopefully the first quarter. And this gives you, the full scripting, the full, and actually Profiler already works. But then you'll be able to modify the metadata. You'll be able to use SQL Server data tools. You'll be able to use, community tools like Tabular Editor and BISM Normalizer and a ton of other community tools to manage and author these Power BI data sets. Okay, so basically, we just expose the Power BI workspace and it acts exactly as though it were an analysis services server. And now you get full backwards compatibility. And then that whole ecosystem of tooling for analysis services by default migrates over to Power BI. All right, it's a beautiful thing. All right, so that's the XML endpoint. And then you just connect to it. So here I've got, for example, DAX Studio connected to the Power BI workspace URL as though it were an analysis services server. Bit of a tongue twister. And as you can see here, this is the Power BI workspace, and I'm connected to the same workspace URL. And then here I am in SSMS, the same data sets listed, and here we are in Profiler. All right, and this is just some of the many tools that can now connect to a Power BI workspace. All right, the analysis services traditional tools. And again, incremental refresh. Avoid you having to write potentially 1,000 or 2,000 lines of Tableau object model code to do. Some of these incremental refresh implementations on analysis services today are really, really complex, right? You do things like auto merging at different granularities, and you detect data changes to refresh only certain partitions where the data has changed. And there's all sorts of complex optimizations that people can do, but you have to write all the code for it. Whereas with Power BI, you fill in this dialog that abstracts all of that. We still generate all the partitions in the back. You can still see all the partitions in SSMS, but you don't have to write the code. You just fill in this dialog and then we do the work for you, right? So that's going to mean that, for example, if you have a 10 billion row data set, the first time you refresh it, it might take a few hours. Subsequent refreshes might take 5 or 10 minutes because it's only going to refresh the data that's changed, all right? Okay, and I will, as I said, I will demo this as well. So time for the demo. I can take a quick pause here to see if there's any questions. Any questions, Michael? Hello?
Sorry, I was on mute. I read the whole question out, I promise. Okay.
No problem.
So Shabir would like to know, is analysis services going away? And with all these changes coming into Power BI, what is the benefit of using Azure Analysis Services?
Okay, so good questions. Thank you for asking that. Azure Analysis Services is absolutely not going anywhere, right? Let's just clear that one. I get asked this a lot, and it's absolutely not going anywhere. If you look at, for example, SQL Server Analysis Services, as I said, it's been around for 20 years, and it will be around for another 20 years. We know, we have rough ideas of how many models have migrated to the cloud, and to be honest, Azure Analysis Services is one of the fastest growing Azure services. We're getting very fast growth rates, but we've only touched the tip of the iceberg in terms of on-premises migrations to the cloud, right? So Azure Analysis Services will always be there based off our current, for the foreseeable future. It will always be there for that kind of straight lift and shift scenario that I just want modeling parity. I want an easy way. I just want to change the deployment server from the on-prem Analysis Services instance to the Azure Analysis Services URL, and I just instantly can spin up a server in seconds, and I can get things like scale out without spending months designing a really advanced scale out solution. I get much better diagnostic logging, and I get those kind of fully managed platform as a service benefits. I don't have to manage a ton of virtual machines. So for that straight lift and shift scenario, Azure Analysis Services will be there for a long time, and it will continue growing at a phenomenal pace for a long time. Absolutely no worries there. But however, so the story with premium is it's really, if I want to modernize my business intelligence architecture, I really want to take, I may have these models on Azure Analytics Services. Let's say and I can migrate straight from SQL Server Analytics Services straight to Power BI Premium, or I can migrate to Azure Analytics Services. So let's say I migrate to Azure Analytics Services and I've got a big 300 gigabyte model on an S9 in Azure Analytics Services. But then I say, well, actually, I want to modernize and I want to get native integration with the rest of the Power BI ecosystem. I want to get all of the other benefits in terms of data connectivity, etc. And then I want to leverage the next generation scalability features like composite models and aggregations, which means that my 300 gigabyte model in analysis services might be a 10 gigabyte data set in Power BI, because I may not need to cache all of that data into memory. I can use composite models and aggregations, and I can make much more efficient usage of memory because of the dynamic memory swapping that Power BI gives you. I want to use the next generation of the tooling in Power BI Desktop and the Power BI tooling, which is going to evolve, and all of those enterprise features will be in Power BI, right? So it's really, it's not going to be as clean a lift and shift story for on-prem to the cloud, but it will really give you the next generation capabilities in terms of modernizing your business intelligence architecture and your business intelligence implementations. Okay?
Great, thanks. Rahul has a question. So he says, while working with Power BI and analysis services model, one important missing feature that he feels is that the end user cannot create additional simple measures, computations, or simple bucketing schemas. Is there a plan to essentially address this?
So sorry, I might need a bit of clarification on that. So you mean you are connected to either a Power BI data set or an analysis?
He talks about multidimensional or tabular and using analysis services.
Okay, so you're connected in live mode to an AS instance, and then you want to kind of enhance that model to add some other data, maybe from a different AS server, and maybe some local data to get matched up.
You refer specifically to measures, which, as far as I know, I can do that.
Yeah, so measures is already supported. You can already be in live connect mode to either analysis services, tabular at least, or a Power BI dataset, and you can already add measures locally that are stored in the PBIX. And we are going beyond that. I don't have any time frames right now, but you will at some point. I just keep an eye on the release notes, because it's they'll land there as soon as we've confirmed the plans. But the plan is that we've already been public about this, that you'll be able to mash up data from different AS instances, maybe with even from Power BI datasets, across Power BI datasets, and that will really kind of enhance your customization capabilities for the self-service analyst. It gives the BI Pro, it empowers the BI Pro, because the BI Pro's models then become more valuable in an enterprise organization, right? It's not something that the BI Pro would typically do to create a kind of virtual semantic model across different AS instances. You'd probably want to create one consolidated model to maximize performance and those things. But once you've created that your BI Pro model, and you've got users all over the organization consuming from it, they now are empowered to mash that up with other data from other AS instances or their own data, which really adds value to your offering as the BI Pro, if that makes sense. Right? So that's planned, and I don't have any time frames for that right now, but watch the Power BI release notes.
Great. Next is Andy, who would like to know the status of incremental refresh in Pro.
Thank you, Andy. I have to be careful what I say. I'm just going to say this, Andy, that I literally had an extensive meeting about this yesterday. I'm going to have another meeting about this today. And it is there's a hive of activity going on, but I'm not ready to make any announcements right now, okay? But let's just say that we said we'd do it, and we still plan to do it. And just watch this space. It could land pretty soon. There's a couple of possible dates that I'm not able to disclose right now, but it could land sooner rather than later, and we are definitely focused on it right now. Okay.
Great. That question was actually from Danny. Andy asks that he's heard of Power BI extended memory. Can you touch on that?
Okay, so we're getting to as I understand the question, it's basically the dynamic memory management capability that we get in Power BI. So with Power BI today, both in shared stroke pro and premium capacities, this is something that is different to the way that analysis services works, right? So analysis services, whether it be SQL Server analysis services on-prem or Azure analysis services, all of the data sets are completely pinned into memory the whole time. Obviously, when you restart the server, it just rehydrates all of the data sets into memory, and once they're in memory, that's it. They're in there and they're stuck there. Power BI, on the other hand, has this capability of evicting data sets and loading them as required. So maybe you've got 20 data sets, but you only need 10 of them in memory at a given time. And then when a user accesses a report that requests data from the 11th data set that is not yet loaded into memory, it will just load it on demand. And if necessary, it will evict one of the other 10 to make room for the 11th one. So it will detect which is the least active of the 10 data sets that are loaded into memory, and it will pick the least active and it will evict it out of memory to make space for the 11th data set, if that makes sense, right? So that's the kind of Power BI dynamic memory management capability. And so this allows you to have a total size footprint of all of your data sets on a Power BI capacity to be greater than the total memory available on the capacity. That's not something you can do in analysis services. And we are enhancing that even further, so that at some point, as we discussed this at the keynote at the Microsoft Business Application Summit this year. So at some point in the next year, we will be doing the same dynamic memory management, but it will be an enhanced version of it that won't need to load the whole data set in and out of memory. We'll actually do it at the column segment level, which will give you, basically that just takes memory out of the equation. What has been the biggest limiting factor in terms of scalability of business intelligence models over the past decade will basically be taken out of the equation. It'll be all about cores at that point, because you'll be able to just swap subsets of data sets in and out of memory on demand. We'll be spinning up, I can't even disclose everything because we haven't announced everything, but let's just say that it's going to be a much more efficient usage of memory. And this is a great example of how Power BI will become the next generation of analysis services in terms of scalability. Okay?
Great stuff. Okay, we've got a couple more questions, but do you want to get to your demo just so we make sure we?
Okay.
And I'll circle back to them.
5 minutes at the end for some more questions. So let's get straight into the demo. So let's see. I've got this Power BI workspace. Right, so I've got these 4 data sets. This is the new UI. It hasn't landed on the public clusters yet. So basically, I've got it filtered by the data sets. So these are the 4 data sets. And to connect to this workspace, and I'm assuming everyone can see my screen. So to connect to this workspace as though it were an analysis services instance, we can come into settings, say premium. And then here we've got the workspace connection, which is the workspace URL, and I can just say copy that into the clipboard. And then here, I'm connected using SQL Server Management Studio to that same URL. SSMS thinks it's analysis services, right? And so does every other major BI vendor on the planet, by the way. You connect and it's just, technically it is analysis services, right? This actually is analysis services, right? And so here I have the same 4 data sets listed. And then here's the thing that we're launching soon. Up until today, your dataset size limit in Power BI is 10 gigabytes, right? So with the large models feature that is going to launch soon, if I come to the properties of this dataset, you'll see that the dataset size is actually 70 gigabytes, right? Way beyond the 10 gigabyte limit, right? So this is running on a P3 capacity, which has 100 gigabytes of memory. So, and I comfortably loaded this 70 gigabyte data set. I had to use incremental refresh to get it in there. But as you can see, this is a big step towards making Power BI a true superset of analysis services. All right. Now, what I'm going to do now is I'm going to connect to this data set from Power BI Desktop. And so this is actually, before I even do that, I'm going to come in here. I want to show you something about this data set, which is the shared and certified data sets feature. So I'm going to come into the settings for this data set, which is the 70 gigabyte data set. And there's this endorsement section down here. As you can see, I've tagged this one as promoted, right? This is basically saying, okay, I'm the BI Pro. I've authored my data sets. I want to promote these data sets in my organization. I want them easily accessible, easily discoverable for users in my organization. This is sanctioned by, this data set is now tested and it's ready for consumption, right? And so I'm going to tag it as promoted. Or I could also take it to the next level, which is to get it certified. Now, to get it certified, I need to go through the data governance process of my organization. So based off my role, I don't even have access to set it to certified, but you can customize this learn more link to have it linked to a page in your organization with instructions of, who to contact, which person in the data architecture group or whatever, or the information management group that needs to be contacted to get this data set certified as the single version of the truth. What does that actually mean? So what that means is that when I connect to Power BI, so I'm here on Power BI desktop, right? So normally I would say get data from analysis services, whereas here I can say get data from Power BI. And this is the same kind of model where I have this separate, the report is not in the same PBIX as the data set, right? The report can be published to any other workspace that I want. It doesn't have to be in the same workspace as the data set, right? This is like the analysis services kind of model where you have these centralized data sets that are consumed by reports in any workspace in your organization, or even out in other organizations, because we have B2B support as well, right? Which is something that's very difficult to do with on-prem. So having done this, I get the promoted and certified data sets right at the top of the list. Now, this is a test tenant, so I don't have very many data sets here. But you can imagine, we know that Power BI grows virally. There could literally be hundreds or thousands of data sets in your organization. You get the promoted and certified ones right at the top of the list. The certified ones would be right at the top, then the promoted ones, and it makes the discoverability that much easier. And another good thing about this experience is that unlike analysis services, your users have to email each other the server names, right? Whereas here, they just say get data, Power BI data set, and they're presented with all of the data sets they have access to in their organization. They don't need to remember the server names, right? So I'm going to go with this one, which is the 70 gigabyte one. So this data set contains data for New York taxi rides across a 12-year period. And so you can see this trip data contains, which has got a ton of columns in it. This trip data contains a row for every New York taxi ride across a 12-year period. And so this measure, which is a report level measure, I think this was actually one of the questions earlier. So this is a live connect report, right? This is the data set is not here in this PBIX. This is just the report. This is exactly the same experience I have with analysis services, right? So I can't change the name of the table, for example. I can't go to the modeling view, but I can add my own measure. This is a custom measure, right? I can say, add a new measure, which is exactly what I did here, which is why you can see the DAX for it. If I go to this measure, this one is the trip count in the model. I can't see the DAX for it. This one I added locally in the PBIX. I can see the DAX, and this is simply the count of the rows in the trip table. Nothing particularly special about that. So let's drag this onto the canvas and see how many rows we have in here. So just casually drag it onto the canvas, blah, blah, blah. Just another day at the office. And we have over 3 billion rows. Now, with aggregations, you can get to a much larger data set. But the difference here is that the whole data set is cached into memory from top to bottom, right? From the aggregated 3 billion row aggregated cell value all the way down to the individual taxi rides. The whole thing is blazing fast performance at any level, whether the aggregated or the leaf level. I'm going to get really fast performance. So let me demonstrate. So I'll go with maybe revenue per trip. We'll break it out by the top 10 zip codes. And as we can see, we have 2 clear outliers here. We naturally want to visualize this on a map. So we will bring in these. So these are high cardinality columns, these longitude and latitude, which increase the size of the data set significantly. But and these are down at the leaf level, right? But as you can see, because I've cached the whole data set into memory, even down at the leaf level, where each one of these bubbles, this is, you know, this is a representative of the 3 billion row taxi ride. So there's an individual pickup location for each taxi ride, and so this map is effectively at the leaf level, and I'm still getting really fast performance, right? So if I click on here, I can just zoom into JFK. I'm just getting this clicky, draggy, droppy experience. I'm getting instant response times, you know, really nice, pleasurable experience across this really big data set, right? So this is 70 gigabytes. This is about 1.5 terabytes in its raw uncompressed form in the kind of CSV file. So after compression, we're getting to 70 gigabytes. We're getting 3 billion rows. And the point being, I can go from the 3 billion row aggregated cell value all the way down to the individual pickup locations, right? That are actually the individual taxi pickup locations, which, as you can see at JFK, we have this interesting phenomenon where people are running out on the freeway to catch taxis, right? But that's the point. You know, we've unlocked this 3 billion row data set, blazing fast performance from top to bottom. Okay, so that's the large model's experience from the consumer. And so how did I build this? Well, as I said, I needed to use incremental refresh. How did I do this from the modeling standpoint? So I've got this taxi data set here. This is the same model, but this is in Power BI Desktop. So you may ask, how can I even have this in Power BI Desktop? I don't have 70 gigabytes of memory on my machine. Right. Well, that's true. Unfortunately, I ask Microsoft for a 70 gigabyte machine all the time, and for some reason they keep saying no. But the point being that this PBIX doesn't have all 3 billion rows of data in it, right? In fact, if we come into the edit queries, you'll see that this trip data is filtered on. If I show you the M expression for this, this is filtered just on the data within these two parameters. And these two parameters, as you can see here on the left, range start, range end, these are kind of reserved name parameters that you can set up in Power Query that are going to act as your filter on your big fact table, right? So here I've only got 3 days of data. I've only got the data between October 1st and October 3rd. Right? So I don't have, you know, all 12 years of data. I've only got 3 days of data, which is why my PBIX is so small. So these are date time parameters, but you can do things like you can use these Power Query functions if you've got maybe integer surrogate keys like, you know, 2001, 0101 or something like that. You can use these functions as long as the logic is folded down to the source, so that you push that filter down to the source, then you're fine. So you just need to make sure that the logic is filtered down to the source. So this is way easier than trying to write the 2,000 lines of code in Tableau Object Model to manage incremental refresh of partitions, right? So I set this up, and now my data only has data between, here in the PBIX, only has data between October 1st and October 3rd. And I can now, having done that, I can come and set up an incremental refresh policy. So this is only I need to have it filtered by those two parameters because once it generates partitions in the service, it actually invokes the query for each partition, and it parameterizes the query for each partition using those parameters, because each partition has a date range, right? So those parameters serve two purposes. One is to limit the data I have in Power BI Desktop. Number two is that the partitioning logic in the service will utilize them as well. Those values of October 1st and 3rd make no difference in the service. All right, so having done this, I can now specify this incremental refresh policy, which says that no matter how many times I refresh it here in desktop, I'm only going to get those 3 days of data. But once I publish it to the service, as it says right here, right? Once you've published it to the service, the first refresh will take a lot longer because it will load all 5 years of data. Subsequent refreshes will load only the last 10 days up to that date. And there's some more advanced things you can do in terms of detecting data changes and things like that, which I haven't got time to explain right now. But so you can set this up in the dialog. You don't need to write all the code. Having done this, I can now publish this data set to my workspace. Currently, it's listing only the premium ones, as the person asked earlier. We hope to have it working in Pro soon so that this validation will be relaxed. And so if I want to push this to my finance corporate workspace. So it's now in the workspace. And so now I've got my data set in this workspace, which is right here, right? So it's this IR taxi. Actually, no, let me do it from SSMS. So I've got, let's go to this workspace. I've got these data sets, right? So here's my IR taxi data set, incremental refresh taxi. And if we look at the partitions right now, if I've just published this from Power BI Desktop, it has only got a single partition in it because Power BI Desktop doesn't know anything about partitions, right? So it's only once I invoke the refresh that we're going to get the partitions generated. Oh, and by the way, I had to enable this data set for large models, right? Otherwise, once it goes beyond 10 gigabytes, I get an error. Now, there will be a checkbox in the dataset settings to denote a dataset as a large models dataset in the not too distant future. But in the meantime, you have, for the public preview, you will have to set it using PowerShell, right? And so this is it's very, very simple. You just log in. This is the Power BI management module. You log in, and then you run this commandlet to say, you know, whether the storage mode is premium files or not. So these large models are actually stored in Azure premium files. I don't want to deviate and talk about that too much right now, but it's a lot more efficient than Azure Analysis Services that stores the data in blob storage. Like, it's encrypted at rest in both cases, and then it's hydrated into memory. But it loads a lot faster from premium files, which is why we're going to do the enhanced dynamic memory management that we discussed earlier. The premium files is an enabler for that as well. So this one's already set up for premium files. To set it to premium files, I would just run this commandlet. I just put in the dataset ID, which I can get from the URL in the Power BI service. So having done that, right, so I'm all set up now, right? So I've got my dataset is up there. There's only one partition in it right now because I haven't refreshed it yet. But I've enabled it for large models, and I've set up that incremental refresh partition. So I'm all set up. That's all I have to do. As I say, this is a lot simpler in terms of the management experience than analysis services. So what I'm going to do now is I'm going to invoke a refresh operation on this data set. So let's go ahead and do this. Maybe I get a timeout. Let's see on whether no, SSMS is still connected. So to generate this tabular model scripting language refresh command, I can say process table, and then I can script it out. If I just say script, it will generate something like this. And so this is now generating all of those partitions, right? So as soon as this is done, we should be able to see all of them. There it is. So if I come back in here and we refresh this, we can see all of these partitions that were generated. And so we've got multi-grain partitions, right? So I said I wanted the 5 years, which are these 5 years, and then it then has some quarters and a month and a few days, and all the way up to the current date, which I overrode by setting the effective date in the command. So it's gone all the way up to August 14th, right? And so the reason it's gone down to the day level in terms of the granularity of the partitions is to maintain its policy that every time I do a refresh, it's only gonna refresh the last 10 days or the last 10 partitions, right? And so that's why it needs these ones at the day level, whereas the historical ones, for better compression, can just be merged up into the year or into the month or the quarter of the year. So if I roll forward by 1 day and I run this again, so what it will do now is it will generate a new partition for August 15th, and it will also opportunistically merge the partitions into months and quarters and years to get better compression. This is the type of optimization that was super challenging to do in analysis services because, again, you'd have to write all the code. So having run this, and now if I refresh this and then sort it again, you'll see we got the new partition for the 15th. And the other thing I want to point out here is that if you look at the last process time, there's a gap of about a minute for these partitions and the previous ones, because when I ran it a second time, it only refreshed the last 10 days. It maintained the contract that I've already loaded all the history. I've already loaded the billions of rows of data. I don't need to reload all of that, right? I just want to reload only the last 10 days, which is going to make the refresh much, much faster, and it's going to allow me to meet my SLA. Okay, so that's it in terms of the demo. I'm right on time, but we can open it up for any last questions.
Okay, so we've got a couple. So just guys, if you want to drop out, feel free. I know some of you guys have to end up on the hour, but Christian, if you're happy to hang around for 10 minutes or so.
Yes, no problem.
Okay, so Yatsik would like to know our current SSAS multi-dimensional cube is 5 terabytes compressed. We couldn't use Azure Analysis Services due to the memory limit. What would be the roadmap going forward for him?
So the roadmap going forward would be to potentially look at the next generation scalability features in Power BI Premium. So you'd probably so we got things like, I don't know if you've seen the trillion row demo where I have a quarter of a petabyte data set with 1 trillion rows, and I'm getting that same kind of clicky, draggy, droppy user experience. And the way that that is achieved is that we cache only the aggregated data into memory, and then detail level queries get submitted in direct query to the data warehouse. So that is a new way of doing it that is only supported in Power BI. And so that is something that you could look at. You'd probably still need the large models feature for a data set of that size. Even the aggregated data itself might still be reasonably big, but you would at least not need to have a multi-terabytes of memory on the server. So that's one good option. Yeah, that's probably the leading option at the moment. There are a few others, but that's probably the leading option. Again, once we bring all of that application lifecycle management and really make Power BI a superset of analytic services in the coming months, you would then be able to seamlessly migrate to Power BI and make use of those features like composite models and aggregations to unlock way bigger data sets than what even multidimensional can handle today.
Great. So the next question comes from Shabnam, who coincidentally is our next speaker, who will be speaking about aggregations.
Hello, Shabnam.
She would like to know, is there a plan to bring aggregations to on-prem and Azure Analysis Services?
Not currently, Shabnam. We're focusing on going the other way, as I say, to bring all of the analysis stuff. There's so many things that we need to make Power BI support, like diagnostic logging and firewall and scale out. So we're really focused on bringing the analysis services features to Power BI. And even if we were to enable it in the engine, there's no tooling for it. So it's not in the current plan. We'll see how it goes in the future, but as I say, we're focused on going the other way.
Great. Okay. David would like to know, it seems that analysis services is a much fuller featured in Excel Power BI than in Azure Analysis Services. Is there a plan to provide a small capacity, less than $100 per month? Assuming here he's talking about Azure Analysis Services.
Sorry, I'm not sure I understood the question fully. So sorry, can you answer that again, please?
It seems like analysis services is much fuller featured in Excel Power BI.
In Excel Power BI, I'm not sure what that means. Do you mean Power Pivot in Excel, or do you mean?
I think it means the Vertipack model in Power BI is further ahead. It has more recent features, which makes sense because of the monthly release cycle, I guess. Okay. But then he wants to know, and it seems to be a separate question, maybe it's a statement then, is there a plan to provide a smaller capacity, assuming analysis services for less than $100 per month? So,
and Azure Analysis Services already has a dev SKU, which is $98 a month. So
all right.
Right within the criteria. Right within the criteria there. So yeah, and actually Azure Analysis Services gets updated very frequently, because it's a cloud service. So that's one of the luxuries of a cloud service, is that you get the new versions much quicker. So yeah, I think we got that. If you want to check it out, you're welcome to check it out.
Right. Okay. Bill would like to know, would this architecture of using larger data sets and segment level memory paging provide better overall performance than using aggregations on top of Azure DW?
So yeah, I get this question sometimes as well, like which one would I choose, right? So it would give you better performance, because even if you go down to the leaf level, you're still going to be getting the in-memory, even though it may have to load it from premium files, or it may have to load it into memory on the fly, but it's still going to be a lot quicker than running a direct query on your data warehouse, even though that could be optimized as well. But so generally, you'll get better performance if you have an in-memory representation of the whole data set. And with the dynamic memory management, you don't need to load all of the data. You don't need to have all of the data loaded into memory at one time. So why would you ever use aggregations then, you might ask? Well, the reason is that, aggregations, this is much cheaper to manage, right? You don't need to refresh these massive amounts. Even with the dynamic memory management, you still need to refresh all of that data to have the Power BI representation of it, so that it doesn't need to submit the direct query. Whereas with aggregations and composite models, you're more dependent. You're achieving this kind of balanced architecture where you're using the resources across both Power BI and the data warehouse, and your refresh times are going to be way quicker because there's a lot less data to refresh, and the management overhead of refreshing it is a lot less as well. And then you get other benefits like, near real time. You can set up an aggregation that's on a materialized view in SQL Data Warehouse, for example, and that's going to automatically get updated with new data. So that gives you a really nice performance near real time solution, which you can't get with when you cache all of the data in Power BI. So there's pros and cons of each, but they're both next generation scalability features.
Great. Second question by Bull. Bull would like to know, why are you using bidirectional cross filters everywhere? He thought they were bad.
Where did I? I'm not sure I used any bidirectional cross filters. I would only use them on an as required basis if I've genuinely got a requirement for them. And I do agree that there are many implementations out there that use them unnecessarily and have performance issues. However, I don't think I'm one of the culprits. So I will have to, stand up for my innocence on that one, I'm afraid.
Okay. Final question from Yitzhak. Would like to know about NUMA support within Azure Analysis Services. Is this still a weak area?
No, I mean, actually, I would say it's one of the strengths of Analysis Services, because you spin up the AS instance and we pre-configure all of that NUMA stuff for you. On-prem, we've seen a ton of customers that provision their standard hardware specs, and they get these servers, and they don't even work well. They're not even geared to Analysis Services. We've already had our top architects select the hardware that works best with Analysis Services, and depending on which SKU you select in Azure Analysis Services, it's already pre-configured for NUMA. Right? So, maybe that's not like, there'll be some very corner cases where you could, have more expensive hardware for more specific requirements. But by and large, we see the much bigger problem on-prem is to have hardware that either isn't configured properly, people don't understand NUMA, or they buy the wrong hardware that doesn't work well with NUMA. And so Azure Analysis Services, while it may not be the most optimal hardware for every single type of scenario, on average is going to be much better because you don't need to worry about that, and it's pre-configured for NUMA depending on what SKU you select.
Great. Okay, so that was the last. Well, there's one last question from Mike, who's just asking for the URL. I will send that out tomorrow. So in 24 hours time, you will get an email with the link to the content. So that will go out to you. But Christian, I want to thank you again for coming to talk to our user group. I hope they all learned something, and I hope we see a lot of cool features coming out really, really soon.
Awesome.
And we'll see you all. It's going to be passed, so there's going to be no sessions for about 3 weeks. But as we've mentioned, Shabnan will be speaking in 3 weeks about aggregations. Right, awesome. So I'd like to thank everyone. Just a reminder, you'll be getting a questionnaire. If you could please fill that out, provide any sort of useful information, we'd really appreciate it. All right, so thank you and goodbye.
Thank you very much. Bye-bye.